Astronomy in Ancient India. Today we are going to discuss about various astronomical theories and practices, which were prevalent in ancient India. Astronomy has a long history in Indian subcontinent stretching from prehistoric to modern times. Some of the earliest roots of Indian astronomy can be dated to the period of Indus Valley Civilization or earlier. Astronomy later developed as a discipline of Vedanga, or one of the auxiliary disciplines associated with the study of the Vedas, dating 1500 BCE or older. The oldest known text is the Vedanga Jyotisha, dated from 1400 to 1200 BCE, with the extant formed possibly from 700 to 600 BCE. Indian astronomy flowered in the 5th and 6th century, with Aryabhata, whose work, Aryabhatiya, represented the pinnacle of astronomical knowledge at the time. The Aryabhatiya is composed of 4 sections, covering topics such as units of time, methods for determining the positions of planets, the cause of day and night, and several other cosmological concepts. Later the Indian astronomy significantly influenced Muslim astronomy, Chinese astronomy, European astronomy, and others. Other astronomers of the classical era who further elaborated on Aryabhata's work include Brahmagupta, Varahamihira and Lala. Some cosmological concepts are present in the Vedas, as are notions of the movement of heavenly bodies and the course of the year. The Rig Veda is one of the oldest pieces of Indian literature. Rig Veda describes time as a wheel with 12 parts and 360 spokes or days, with a remainder of 5, making reference to the solar calendar. As in other traditions, there is a close association of astronomy and religion during the early history of the science, astronomical observation being necessitated by spatial and temporal requirements of correct performance of religious ritual. Thus, the Shulba Sutras, texts dedicated to altar construction, discusses advanced mathematics and basic astronomy. Vedanga Jyotisha includes the details about the sun, moon, nakshatras, lunisolar calendar. The Vedanga Jyotisha describes rules for tracking the motions of the sun and the moon for the purposes of ritual. According to the Vedanga Jyotisha, in a yuga or era, there are 5 solar years, 67 lunar sidereal cycles, 1,830 days, 1,835 sidereal days and 62 synodic months. The classical era of Indian astronomy begins in the late Gupta era, in the 5th to 6th centuries. The Pankasiddhantika by Varahamihira of 505 CE approximates the method for determination of the meridian direction from any 3 positions of the shadow using a gnomon. By the time of Aryabhata the motion of planets was treated to be elliptical rather than circular. Other topics included definitions of different units of time, eccentric models of planetary motion, epicyclic models of planetary motion, and planetary longitude corrections for various terrestrial locations. Calendars of Ancient India. The divisions of the year were on the basis of religious rites and seasons or ritu. The duration from mid-March to mid-May was taken to be spring or Vasantha, mid-May to mid-July, summer or Grishma, mid-July to mid-September, rains or Varsha, mid-September to mid-November, autumn or Sharad, mid-November to mid-January, winter or Hemanta, mid-January to mid-March, the dews or Shishir. In the Vedanga Jyosha, the year begins with the winter solstice. Hindu calendars have several eras. The Hindu calendar, counting from the start of the Kali Yuga, has its epoch on February 18, 3102 BCE Julian. January 23, 3102 BCE Gregorian. The Vikram Samvat calendar, introduced about the 12th century, counts from 56 to 57 BCE. The Saka era, used in some Hindu calendars and in the Indian national calendar, has its epoch near the vernal equinox of year 78. The Saptarishi calendar traditionally has its epoch at 3076 BCE. J. A. B. van Buitenen in 2008 reports on the calendars in India. The oldest system, in many respects the basis of the classical one, is known from texts of about 1000 BCE. It divides an approximate solar year of 360 days into 12 lunar months of 27 days, according to the early Vedic text Taittiriya Sahit, or 28 days, according to the Atharvaveda. The resulting discrepancy was resolved by the intercalation of a leap month every 60 months. Time was reckoned by the position marked off in constellations on the ecliptic in which the moon rises daily in the course of one lunation, which is the period from new moon to new moon, and the sun rises monthly in the course of 1 year. These constellations, nakshatra, each measure an arc of 13 degrees 20 minutes of the ecliptic circle. The positions of the moon were directly observable, and those of the sun inferred from the moon's position at full moon, when the sun is on the opposite side of the moon. The position of the sun at midnight was calculated from the nakshatra that culminated on the meridian at that time, the sun then being in opposition to that nakshatra. Some of the astronomers of ancient India are Laggada, Bharibhata, Brahmagupta, Varamihira, Bhaskara I, Lala, Satananda, Bhaskar II, Sripta, Mahendra Suri, Parmeshvara Nambudiri, Nilkantha Somyaji, Desabla, Asiyuta Pisarati, Dinkara, Mathuranatha Sarman. We will learn about these astronomers in the next video. Instruments used in India for the purpose of astronomy are. Among the devices used for astronomy was gnomon, known as Sankhu, in which the shadow of a vertical rod is applied on a horizontal plane in order to ascertain the cardinal directions, the latitude of the point of observation, and the time of observation. This device finds mention in the works of Varahamihira, Aryabhata, Bhaskara, Brahmagupta, among others. The cross staff, known as Yastiyantra, was used by the time of Bhaskara II. This device could vary from a simple stick to V-shaped staffs designed specifically for determining angles with the help of a calibrated scale. The clepsydra or Gatiyantra was used in India for astronomical purposes until recent times. Ohashi in 2008 notes that, several astronomers also described water-driven instruments such as the model of fighting sheep. The armillary sphere was used for observation in India since early times, and finds mention in the works of Aryabhata in the year 476 CE. The Galadipika, a detailed treatise dealing with globes and the armillary sphere, was composed between 1380 and 1460 CE by Paramesvara. On the subject of the usage of the armillary sphere in India, Ohashi writes. The Indian armillary sphere or Golayantra was based on equatorial coordinates, unlike the Greek armillary sphere, which was based on ecliptical coordinates, although the Indian armillary sphere also had an ecliptical hoop. Probably, the celestial coordinates of the junction stars of the lunar mansions were determined by the armillary sphere since the 7th century or so. There was also a celestial globe rotated by flowing water. An instrument invented by the mathematician and astronomer Bhaskara II in the year between 1114 to 1185 CE consisted of a rectangular board with a pin and an index arm. This device is called the Falakayantra and was used to determine time from the sun's altitude. The Kapalayantra was an equatorial sundial instrument used to determine the sun's azimuth. Kartarayantra combined two semicircular board instruments to give rise to a scissors instrument. First mentioned in the works of Mahendra Suri, the court astronomer of Firoz Shah Tughlaq, the astrolabe was further mentioned by Padmanabha in the year 1423 CE and Ramachandra in the year 1428 CE as its use grew in India. Invented by Padmanabha, a nocturnal polar rotation instrument consisted of a rectangular board with a slit and a set of pointers with concentric graduated circles. Time and other astronomical quantities could be calculated by adjusting the slit to the directions of Alpha and Beta Ursa Minor. Ohashi further explains that, its backside was made as a quadrant with a plumb and an index arm. 30 parallel lines were drawn inside the quadrant, and trigonometrical calculations were done graphically. After determining the sun's altitude with the help of the plumb, time was calculated graphically with the help of the index arm. The observatories constructed by Jai Singh II of Amber. The Maharaja of Jaipur, Sawai Jai Singh, who reigned from 1688 to 1743 CE, constructed 5 astronomical observatories at the beginning of the 18th century. The observatory in Mathura is not extant, but those in Delhi, Jaipur, Ujjain, and Banaras are. There are several huge instruments based on Hindu astronomy. For example, the Samrat, Yentra or emperor instrument is a huge sundial which consists of a triangular gnomon wall and a pair of quadrants toward the east and west of the gnomon wall. Time has been graduated on the quadrants. The seamless celestial globe is considered to be one of the most impressive astronomical instruments and remarkable feats in metallurgy and engineering. All globes before and after this were seamed, and in the 20th century, it was believed by metallurgists to be technically impossible to create a metal globe without any seams, even with modern technology. It was in the 1980s, however, Emily Savage Smith discovered several celestial globes without any seams in India. In 1842, during Jagtajit Singh Bahadur's reign, a Hindu metallurgist Lala Balhumal Lahori produced 21 such globes, and these remain the only examples of seamless metal globes. There are still lots of things to discuss about this topic. But this video will be way too long, if we do this here. Therefore, there will be a second video about this topic. We will also discuss about certain things of this topic in details, in the next video. Thank you for watching this video. If you enjoyed the video, please do consider to hit the like button, also share the video and do consider subscribing to the channel. Your like, share, comments and subscribe will motivate me and keep making more videos.